looking at exponential and logarithmic functions, and about half of this is really going to be algebra review, just reminding us about some of the algebra rules involving exponential and logarithmic functions, and then eventually we'll get to look at derivatives involving these two things. Okay, so just as review, it says the definition of an exponential function: if a is greater than 0, for a not equal to 0, then the exponential function with base a is given by f of x equals a to the x. So we've got a positive number raised to some variable power. And the rules for exponents that you should have learned somewhere along the way still apply for these exponential expressions. So let's take a look at those rules just briefly. Of course, a to the 0, as long as a is not equal to 0, is 1. If we have a to the x times a to the y, it's a to the what? X plus y. Okay, when we multiply, as long as the bases are the same, then we get to add the exponents. Okay, for division, when the bases are the same, we subtract the exponents. So a over x, or a to the x over a to the y, is a to the x minus y. Is that me? Okay. And then we've got a to the x to the y is a. If we have a variable expression or an exponential expression raised to a power, then we can multiply those powers. Okay? Everybody clear on that one? All right. Then we've got a times b to the x. This is where we get a to the x, b to the x. Okay? And I like to just make a point here that, you know, there is no rule up here for a plus b to the x. Okay, sometimes I don't think we've had too much of a problem with that, but sometimes people like to distribute the x, the exponent over a sum. There's no rule that allows us to do that. Okay, the only time we can distribute that x is when it's over factors like it is here. So a times b to the x is equal to a to the x times b to the x. Okay, and then same thing with the quotient. We've got over b to the x is a over x over, or a to the x over b to the x. And then finally, a to the negative x equals 1 over a to the x. If we have a negative exponent on a factor, we can move that factor from the numerator to the denominator or vice versa, and the exponent becomes positive. Okay? Questions about that? All right, you should have seen in your algebra course, kind of stems from one application is where we're having compound interest. You know, you can compound yearly, you can compound semi-annually, you can compound monthly, compound daily. The more often we compound, the better amount of time, what would it be? And so it tells us here, the irrational number e is defined to be the limit of 1 plus x to the 1 over x as x approaches 0. Okay? E is the limit as x approaches 0 of 1 over x. And that looks slightly like what you may have seen in the formula for compound interest. Okay, you don't need to do anything with this, just lets us know where e came from. Alrighty. So using those properties, can we simplify these expressions that involve e? And I guess I should have told you exactly what e, well, not exactly what it is, but approximately. Okay. Just for reference, E is approximately 2.71828. Okay, but we'll look at where it's built into our calculator. Okay, we're going to look at these properties with E. If I have 1 over E to the negative 2, okay, if I'm careful, I might distribute this as 1 over E to the negative 2, because I could distribute that negative 2 to the numerator and denominator. I didn't put it on my numerator since it was just 1, so it's still going to be 1. But if I want to make this positive, then this becomes what? E squared. Okay? With B, we've got E to the 5th over E squared to the negative 1. So we get E cubed to the negative 1. Okay, I dealt with the inside first. I was able to subtract my exponents. And so now I was left with E cubed to the negative 1. That's the same thing as what? 1 over E cubed. Okay. And then in C, we've got E to the negative 4 times E to the negative 3/2. Because I'm multiplying and my bases are the same, I can add the exponents. Three halves. Which is E to the negative 11/2, or 1 over E to the 11/2. Okay. Questions about that? Very good. All right. So what about derivative involving E to the X? Okay. Actually, not that difficult. It says let U be a differentiable function of X. Okay. The derivative of E to the X is just E to the X, believe it or not. If we went through that whole limit process, we prove it. And in fact, this textbook is pretty good about showing you where all of these rules come from. I won't take time to go through. We'll just accept this as fact. All right. The derivative to the X is E to the X. Okay. However, if instead of simple X here we have some function U, then we have to use the chain rule. So the derivative of E to the U, where U is a function of X. Okay, the derivative of E to the U is E to the U du dx. We've got to take the derivative of that U. Okay, using that chain. All right, look at like. All right, we got y prime equals e to the 1 minus x. All right, so that's the e to the u part. Now the derivative of 1 minus x is what? Negative 1. Okay, so we might just say y prime equals negative e to the 1 minus x. All right. Okay, if we've got y equals to the okay, because we're going to need that 1/2 to take the derivative. Then prime is e to the x to the 1/2. Okay, that's the e to the u part. Now I need to take the derivative of x to the 1/2. So that's 1/2 x to the negative 1/2. Okay, and then we can clean it up. But any questions about that before we go on? Yes? Okay, I was taking the derivative of this piece, and since this is an exponent, this was just like any x to the n when I started to take the derivative of it. So I brought the 1/2 out front and then subtracted 1 from the exponent. Okay. All right. When I clean this up, the e to the x to the 1/2, or I might go back and write that as square root of x now. That's up top. We got a 2. Okay. Technically this is up top, but if I move it to the bottom, the exponent becomes positive. So x to the 1/2, or again, you could say square root of x. Questions about that? Okay. All right, with this one, C, we've got y equals 4 e to the x. Okay, well, the 4 is a constant multiple. It goes along for the ride. Derivative of e to the x is just what? E to. All right, and that's. We took the derivative of x, but the derivative of x would be what? Just 1. Okay? All right, why don't you tackle D, E, you come up with, and we'll check them out. How many people got this answer for D? Negative 4 e to the negative 4x. Okay, any questions about that? Okay, and for E, I ended up negative x squared times e to the x cubed over 5. Questions about this one? Okay, and then g of x, I got g prime of x was equal to 3x squared minus 10 e to the 2x. Question? Okay, very good. All right, well, in G, what do you think we would do? What do we have in G? It's a what? Quotient. So we have to use the quotient rule. Okay, so we're going to do low derivative of high minus derivative of low all over low squared. So g prime of x equals x to the 6, okay, derivative of high, which is going to be e to the 3x times 3. Okay, so that's low d high minus high d low, which is 6x to the 5th, all over low, which is x to the 12th. And then we need to factor out. Okay. What can we factor out? To the 3x and also x to the 5th. Okay. So if I do that, and like 6. Okay, now I can cancel x to the 5th with x to the 5th in the bottom. That gives me x to the 7th. So I get e to the 3x times 3x minus 6 all over x to the 7th. Questions about that? Okay. All right, any questions about G? Okay. What about H? What do we need to do there? Product rule. Okay, we've got x to the 7th times e to the 4x. So we're going to use a product rule. And we get y prime equals first times the derivative. All right, and then factor out if we can. Again, it looks like we can factor out e to the 4x and x to the 6th. We're going to be left with 4x plus 7.